Oh, the lights are dimmed. I guess that means we're ready to go. Hello, everybody. Merry Christmas, my liege. That's a very niche joke about a late 90s video game that I don't expect any of you played. And can you tell I'm ad-libbing? Hello, and welcome to Fusion, everybody. Bit rusty there, I think, to start with. I have got a cold, so that was about as enthusiastic as how I feel, which is about as healthy as Matt Hancock's integrity. Hello, everyone, and welcome to Fusion. There we go. That's it. That's a bit better. It's Christmas time, which obviously means pizza. Let's hear it for Rudy's. I love Rudy's pizzas. So, I obviously do my stupid spiel at the start for my team to sort of groan. I couldn't really. There was a really sort of obvious way to start off this, really, which is going to be Chat GPT. Is it GPT? I can never remember what it is. Is it Chat GPT? And so I saw this online. I thought, this is great. Tell me a scary story about software. Once upon a time, Slack was purchased by Salesforce, then Figma was purchased by Adobe, Notion was bought by Microsoft, and Linear was acquired by Atlassian. Make it scarier. Have to use Windows at work. So, as soon as I sort of dabbled with this, I thought it'd be very funny, but obviously, for anyone that was at the last Fusion, you do know that I mostly kind of hate my team that I have to work with, because they basically just troll me non-stop, and it's a nightmare. So, like James Vickery's like, well, I'll tell you what, if we've got this, is there a need for a gym? So he's like, go on then, I'm going to feed the algorithm. My team suck and are trying to get me sacked. Fusion is a quarterly technology meetup in Birmingham. Today's meetup will have 2 full-length talks and 4 lightning talks. Food will be provided by Pytanic, let's not explain that, who are serving pizzas. Some interesting news recently has been Elon Musk buying Twitter and OpenAPI, building a new chat-based AI tool. Please write an informative, interesting, and funny introduction to the meetup. I must say, that is very polite. I think people are putting some far more trollier things. Anyway, off we go. Welcome to Fusion, the quarterly technology meetup in Birmingham. We're excited to have you today for a great lineup of talks. This is making my job very extinct, isn't it? Including 2 full-length presentations, 4 lightning talks, and don't forget to fuel up with some delicious pizzas provided by Rudy's Pizzas. In case you missed it, there have been some interesting tech news recently. Elon Musk, the CEO of SpaceX and Tesla, recently bought Twitter, causing quite a stir on social media. That's very formative, isn't it? And a team at OpenAI has been busy building a new AI tool that uses natural language processing to have intelligent conversations. So without further ado, let's dive into today's talks and learn about the latest and greatest in tech. But James wouldn't let this slide because he was like, it's all right, but please make it funnier. Factoring in jokes about Elon and randomly turning Twitter's microservices off, and how this introduction was written by an API. It's similar, but now it tries to be funny, and it's quite funny seeing the open up. Now, I'm sure you've heard the news about Elon Musk buying Twitter and causing chaos on the platform. I mean, who knows what they'll do next? Will he randomly turn off Twitter's microservices off for fun? Only time will tell. That's a bit lame, isn't it? And speaking of AI, and then it basically plugs itself. I mean, you did tell it to plug itself, didn't you? But quite importantly, I like this. That's right, I'm not going to lose my job here, because it says, that's right, even if the jokes are generated by a machine, so if you don't find them funny, don't blame me, blame the algorithm. Right, on to sponsors. Let's hear it for Goldman Sachs. These are people that make these things happen. Got some crew in tonight. And for Vonage, we're not going to have such a big one, but big one because I'm the only Vonage person here tonight. And I'll get back to you on some quite cool slag. I didn't say that. Some quite cool swag that you can get. I say this every time. It's really the sponsors are what makes these events happen. So if you are working at a company where you want to talk to us about sponsorship opportunities for Fusion, because it's not cheap to run events like this. They cost a lot of money. Then please approach one of the team that are wearing these hoodies. courtesy of James Vickery, whilst I was just abusing him, we have a brand new sparkling website, which is very shiny and very lovely. And so I'd like to thank him personally for doing that, because my front end is terrible and I couldn't do it. There it is. Go and check it out. It is now actually being updated and up to date, so you can actually see past events, you can see recordings, live feeds, things like that. And something I've been missing off loads of my slides recently for all events, please, if you are tweeting us on the socials, whether it is the Mastodons or the tweet or the tweeting, or what's the other one that has got a really big security risk, Hive. That's there you go, like a couple of nods in the audience. Fusion Meetup for the hashtag, please. Thank you very much. Partnerships, kind of what kind of drive us to what we do. So this is kind of really sort of hasn't really changed. So School of Code, Hack the Midlands has just been. Birmingham Design, Stuart, we'll talk about him in a minute, Cryogenics and Code Your Future. And of course TechMids, for anyone that's not seen this for the first time, TechMids incorporates the sort of general engineering ecosystem. So that incorporates people speaking to all of these fine meetups in the region. Some dates for the diary, and I've been very clever, well, at least I think I've been clever in QR code these. The Christmas party for TechMids is happening on the 16th of December, which is at Tilt. If you haven't been to Tilt, it's pinball and craft beer and craft coffee. All of the things that serve your hipster needs. And we've got quite a few dates coming in from Dave Evans running .NET and Xamarin. December the 14th, January the 11th, and February the 8th. Got 3 different meetups there if you want to hit the link. And ManageOps has been pretty successful, where I think it's been pretty much sold out every time. So if you're involved in engineering management, or you have, it's not just for managers specifically, I think it's for driving any kind of, what would you call it, like responsibility? Something, because there's individual contributors when you have ownership, so it's still kind of relevant. They're kind of taking a bit of a pause at the moment, but they're starting back up in the joint works in the Jory Quarter. I highly recommend that location. It's really, it's got a really cool kind of co-working space. That's on the 24th of January. I'm going to call Stuart to the bar. He is actually just here. On the 29th of December in Birmingham, we have Stuart's infamous Xmas pub crawl. Ask Sil and make sure you pace yourself, because it can be brutal. Stuart's just staring at me.
I completely forgot I said I'd say something. Right, so every year in between Christmas and New Year, there's a chance for people to get together, because some of you may go home and hang out with your families and have a great time and that's it, and not come back to work until January. Whereas some people are like, I've now gone 4 days and I haven't talked about the has selector in CSS and it's doing my head in. And I'd quite like the opportunity to talk about technology with people rather than politics or Turkey or whatever. So there is the chance to come and hang out with people in between Christmas and New Year. I hadn't decided whether it was the 29th or the 30th, so apparently Jim has decided for me, so it's the 29th. Thanks for that. I'll make a note. But the way it works is we'll start at a pub somewhere in probably the city centre at about 12 o'clock, and it tends to go on for the whole day. But what happens is people drop in for a pint or a coffee. I try and make sure that we're places where you don't have to have a drink. So people drop in for a coffee, just have a chat, leave after an hour. Some people stick around for a good portion of it. So keep an eye out for exactly where we're going to be, because I haven't finished writing the thing yet. But if you're looking to come along, we would love to have you.
Thank you, Stuart. Can I decide the venues as well? Right, last bits. Code of conduct. We have a code of conduct. It's taken from, it's a bit of a cop-out, from conf.codeofconduct.com, which I think is from the, Eli will probably correct this, it's from the Python Foundation. I have a feeling it is. Wouldn't that one? But yes, you can see it there, but the long and short of it is be nice to each other, and if you start judging people on race and sexuality and things, if you feel like there is a violation, come to us, anyone that's got the Fusion hoodies on, and then they will be dealt with accordingly, according to the code of conduct. We have something just for now, because this is the. I think this is going to be the sort of the last one of these events that Vonage is sponsoring. We're going to be moving into workshops and things. So we're going to have an anagram challenge, and the prize. There are 3 of them, and they are these. And I'm very jealous because I don't have this swag myself, but it's actually full of goodies as well, including a scarf that is really fancy, and I'm a bit annoyed with my team. So there are 3 of them. I'm going to put them up. I'm not going to ask anyone to solve them on the spot because we have time and anagrams. You didn't come here to see me spout. Be the first to shout at. Be the first to come up to me afterwards if you want one. After all the talks, give me the one that you've solved. You will have to get in quick because there's no formality. That is the first one. So if you can take a photo or you can write it down. Envious Fango Vols. Next one. Still see cameras in the air. Right. Comic maintains soup. And carrots perversely shimmed. So, it's good anagrams, aren't they? Those are the 3 anagrams. If you work them out, or you want me to give those to you, again, because obviously this is right at the beginning and there's a bit of a limited time, ask me for them again, but the first 3 first come, first served answers to those will get a Vonage bag of goodies and a fancy swag bag. Thank you for playing. That's sponsored by Vonage. Thank you very much. If you do win one, it'd be nice if you give us a shout out at Vonage Dev, and Vonage does that is our kind of fancy tagline at the moment. Vonage does that. Here are the talks, because you're bored of me. So, first up, we have Luke Brown, who will be probably known to some, I'm looking at the audience, most people here, as one of the founders of TechMids, and who runs Brum.js. Engineering lead at Wealth Wizards, or close enough. There we go. Done my research. But I mean, we probably know you more for the actual kind of work you do in the community, rather than the sort of what does Musk call it? Hardcore engineering. Hardcore engineering. So, would everyone like to give Luke Brown a massive round of applause? And I forgot exactly what it was you're speaking on, but I know that it's people-related and processes, isn't it? I thought. Go for it.
Hello. Can we get a round of applause for Jim's emceeing? It's a tough gig. Some booze in there as well. Wow. Okay, cool. So, can you put your hand up if you failed in production before? Amazing, my people, lovely. Can you put your hand up if that was in the past week? I want to hear this story later. Great, okay, cool, okay. So I am Luke Brown, I'm lead software engineer at Wealth Wizards, or whatever Jim said. And I've got a talk today called Ship Every Day, Fail Every Day. And I'm hoping by the end that I'll be able to convince you that it's actually a good thing to fail, and that we should aim to do it early and often, and maybe even every day. And I hope you enjoy it. So I mentioned that I work for Wealth Wizards, and we're working to automate financial advice. And the reason we're doing that is we want to make it accessible to everyone. There's 34 million adults in the UK who need financial advice but aren't going to get it, because advisors tend to go after the people with the most money, and the people who need it most tend to not have any wealth. So we're really passionate about this, and we want to go as fast as possible. But for good reason, we're regulated. We have the same standards as like a human financial advisor. And if we get it wrong, it's really, really quite bad for people's lives. So we want to make sure that we have those standards, we enforce those standards, and we make it really hard for us to give the wrong advice. But that tends to lead to some behavior that is counter to like a good engineering culture, that you make changes infrequently, you're scared, you introduce loads of manual gates, and you lean away from automation. I'd like to talk through kind of how we've been pushing back against that to try and lean into automation, even though it's really important that we get it right and potentially quite risky, that we push forward regardless. So imagine you're a developer. You log on, it's 9 a.m, you grab a cup of coffee, you're working on a user story. You write some code, you build it, you test it with some automated tests. This is your inner loop. And we've seen loads and loads of effort go into making this kind of internal loop that developers kind of interact with every day really, really great. This is something that historically you might have done kind of 2 or 3 times a day maybe, kind of once for each piece of acceptance criteria you're writing, but now we're in a place where most developers do this tens, maybe hundreds of times a day for every single line of code that you write. But you live in a simulated world. Lots of stuff is mocked out. You're not testing your assumptions. To see whether things are going to work when a user gets their hands on whatever you're writing, you need to go to the outer loop. And this is where your code gets bundled up, you ship it off to production, and you test your assumptions. You find out whether it actually works. And this is fine. But there are 2 things I want to talk about today. That gap in the middle, that little arrow, is your PR process. And it's a little bit misleading, that diagram. It's actually something more like this. Most developers spend, I see some laughs already, brilliant, great. Most developers spend a lot of time either sitting idle or working on something concurrently because of the PR review process. They're going to get a question from their colleague. Maybe they want to clarify some kind of structural stuff. Maybe someone finds a bug. Maybe you need to chat to your team about that bug. Maybe you need to orientate yourself to the rest of the company. Oh my God, honestly, yawn. But like eventually someone will hit approve and then your team tends to follow. And that's fine. Your team have the best of intent and want the best for you and the company. But that can take a day, a week, 2 weeks, a month, a quarter. And all those assumptions that you made in the inner loop aren't getting validated until your code's in hands of real users. Linear B, a tool that we use, say that this is about 5 days on average in the industry. That's about what we saw about 18 months ago. We wanted to change that because fundamentally, you're testing assumptions when you go into production, and until that point, it's all kind of just nice words and feelings. So when you go to production, things can go well or badly. Talking about things going badly. When I first started in development, thanks, Mum, for the photo. When I first started in development, I was the only developer at the company, and it was great. You know, I had a fantastic time. I wrote code, saved it to a server. I didn't really know what I was doing, to be honest, but I had a great time doing it. And my feedback loop was something more like this. I would save some code, I'd go straight into the outer loop, and I'd test my assumptions straight away. Now, this would be considered horrible practice by most people. We're not having that peer review process. We're not talking to our colleagues. And I'm not advocating for this. But what if we could take the good bits of this? What if we could take that, feeling alive for once? Who knows? What if we could close that feedback loop and feel like production is right in front of us? And because we're professionals, because we don't want to, in our case, give someone the wrong advice, make it safe to fail in production too. So if we were looking at closing that feedback loop, we need to kind of acknowledge that not all feedback is equal. We tend to think about feedback in 2 buckets, kind of your behavioral stuff. So this is making sure that when a user kind of logs in, they ask for some financial advice, or we give them a nudge that is behaving as we expect it to, the functionality. And then your structural stuff, your team saying that, I don't really want to own this code in the future. I worry about maintaining this. So if we were to take the behavioral stuff, a lot of this feedback tends to come from someone like a tester, or someone with a tester mindset. And often this feedback can feel like criticism. You've done your work, you think you've done a good job, and someone comes in and they're ready to kind of litter your PR with comments that feel like criticism. It's well intended, but because it's retrospective, it can feel quite harsh, and it can lead to relationships being quite tense. I won't talk on behalf of other people, but if I was better at making friends, maybe I'd have a better time. Developer and operations have historically kind of been at odds with each other. We've seen the advent of DevOps kind of leading to collaboration. There's no more kind of ops looking over the wall to see what the developers have done, and developers walking up to the wall and throwing code over. Like, you work together and you collaborate. That thinking's expanded to security now as well. You don't have your security team come up to you and audit what you've done. You bake your security in. You come and help them coach you and teach you how to build secure applications so that you never build those security flaws in the first place. But that ideology isn't limited to operations and security. What if we included our testers, our product managers, our designers, all the people in our teams? What if we at Fusion started working as dev, sec, test, product, design, ops practitioners? Or what if we just started collaborating more? Because that's the spirit of DevOps, right? Anyone who says that DevOps is a role, I've got to introduce you to Alistair, the organizer of the DevOps meetup, honestly. It's a culture, and it's really about collaboration. And we're doing that collaboration. It's just that we're doing it later on in the process. We're doing that collaboration right there, after we've written the code. And in my view, that's too late. So that conversation being retrospective kind of biases you away from making the right decisions. Someone's invested time and effort in reaching a solution that you might not think is right, but you don't want to say to them that they need to start again. And, you know, there's an incentive to kind of work towards a solution that might not be the best, and you might not have picked it if you were involved earlier in the process. So what if we were able to shift that left? What if we were able to shift that collaboration to before you write a single line of code? Would we be able to get rid of that bug that was found in the PR process? Atlassian say, yeah. And this is what they've been working on for years and years. So they've moved away from quality assurance to quality assistance, that you don't have QAs or QEs to stand there and kind of like criticize after. You have them there to collaborate early in the process and help bake quality in. So one of the ideas, really great reads by the way, one of the ideas in the Atlassian framework is of test kickoffs. We've adopted that, but do task kickoffs instead. So we will pull together anyone who's needed to make sure that feedback is all given up front, and we don't have that behavioral feedback retrospectively after the work is done. Now, we're all adults. If you've got something that's kind of design and functionality and you don't need any input from platform, don't include them. You don't want to waste their time. You want to be respectful. The same goes for quality. If you're doing something that's purely kind of visual, don't include them. Perhaps you need kind of support from a lead engineer to design some architecture. Just have a chat with them. The idea is that it's flexible enough to kind of focus on collaboration rather than a kind of well-defined process. The idea is that you should probably chat to someone for each ticket, but it's up to you to decide who's best to make sure that you get your feedback as early as possible. So we found that when we did this, our QAs were able to give us kind of insight into the edge cases they'd be looking for and help us remove them from the process entirely. Cool. So those meetings, there were 6 people in them. It's quite a lot. We don't really value synchronous meetings. We like to work asynchronously where possible. So what if we could get feedback on the feedback that we expect to get before we do the task? Well, this is something that the internet's been doing for a long time. RFCs underpin kind of all of the technologies that we use day to day. These are requests for comments. Someone will see a problem, propose a solution, and then put it out to anyone on any time zone, anywhere in the world, to kind of put forward comments to help shape the solution. And we've adopted this, and it's worked really well. It's minimized those kind of test kickoff meetings from things that take maybe half an hour down to 10 minutes. And that's our kind of like aim. If something isn't a 5 or 10 minute kickoff, we've probably done something wrong in the process and not defined detail early enough. The important thing is that this needs to be far enough in advance to not block people doing tasks. So as a rule of thumb, we tend to define RFCs 2 weeks in advance. If you are interested in doing this yourself, there's a really great blog post by Gurgley, who writes a newsletter called Pragmatic Engineer. He was an engineering manager at Uber, so he's seen it worked really well there. It's worked really well for us too. So we've got to this place where when we have an idea, we'll write a proposal, we'll get feedback on it, we'll collaborate with our team early, and we got a little bit of feedback afterwards. This is our structural feedback. This is the kind of poor maintainability that people want to help us make better. Perhaps something needs refactoring. Perhaps it's not consistent with what else we've done. So we've kind of got a view that code review shouldn't be the only place where we improve the structure of what we do. In fact, we should be doing that every single hour of every single day. And we need to make that really clear that adding structural improvements is just as valuable as adding behavioral improvements, and give engineering teams the time and space to do that. So we've adopted the Scout rule explicitly across some of our teams, that you should always leave code better than you found it. Continually improve, separate it out from those behavioral improvements, ideally first. So if you pick up a ticket, you're not a fan of how the code's written, it's not consistent with the kind of other engineering work that you've done, perhaps you could refactor it to make it a bit cleaner and make your life easier when you make that behavioral improvement. It sounds really simple, but agreeing what we think good looks like as well. Agreeing the rules of, we've always considered ourselves a functional programming shop. What does functional programming actually mean? We talk a lot about kind of small composable components in our UI, in an event-driven system, in kind of functional, like, back-end code level. But we've never defined what that actually means. And could we go further? Could we automate that? So that in the IDE, there's a Wealth Wizard set of extensions that help you get feedback inside your inner loop before you ever commit that code. We found this works really well, and we found that it helps kind of drop that structural feedback out as well, bake it in to the inner loop. So at this point, we've built a lot of trust with our engineers. We've got pretty much a bit of a superficial review process here. People are kind of, looks good to me, not necessarily reviewing everything. There are still reviews that trigger debates, and we've missed something. But a lot of the reviews, because we have a shared commitment to quality, and we've kind of front-loaded as much of that feedback as possible, perhaps we're in a space where we could think about moving that outer loop to the inner loop. And we've used a kind of approach called Ship Show Ask. This is one of the most transformational, thank you, Siri. This is one of the most transformational things we've done. And it's really simple. And the good news is that you're doing it already. So when you make a change, this is where most of the industry is, and this is definitely where we were. You make a branch, you add your changes, you have some automated checks, and it triggers some sort of discussion on feedback before you merge. This works really well when you're not sure how your colleagues will feel about a new approach. Maybe they need some help to make things better. Maybe they're done for the day and are going to merge it tomorrow. Want to make sure that someone's comfortable with the changes. But it doesn't work well when you've got a shared commitment to quality. It's a fairly cookie-cutter change, and you're pretty confident that it's going to be uncontroversial. What we reach for instead is to show. Instead of requiring people to ask for permission to make their changes, they show other people the changes that they're going to make. So you still raise a PR, you still merge it, but you have the autonomy to decide when you merge it. You merge it straight away, or once you've kind of tested your assumptions out, and people will review asynchronously. They will give you a code review after the merge. And this works really well when you maybe want to kind of share knowledge with other people, show people a new approach that you followed. Maybe you've refactored a common piece of code that's used quite a lot and you want to make sure that they understand it. Or maybe there's an interesting bug. Look at how I fixed this. You could also go full trunk-based development and go straight to shipping on the main line. No code review, no permission. You want to make a change, you commit it to main. Jim's pretty exhausted looking at this. This is the purest approach. People tend to have one of three reactions to this. Either great, I like that you're not putting things into boxes. Or, why aren't you doing trunk-based development all the time? That is the only way to develop software. It's false. Or, why aren't you reviewing everything? That is the only way to make software. This is about giving developers choice. Maybe you added a feature using a really cookie-cutter pattern. Maybe you fixed some docs. Maybe you kind of updated your code based on really concrete feedback. Typically, you don't need to ask for feedback on the implementation of feedback if it was concrete enough. So it's an option. So we've adopted ShipShow Ask. We started out asking 100% of the time, and we moved towards showing most of the time, very occasionally shipping, but we tend to show and sometimes ask. It can't remove the kind of ability to talk to each other. We spoke before about collaboration, and pull requests are a great way of talking about code, but it does encourage the kind of anti-pattern of thinking that it can remove all conversations about code. Pull requests aren't the only way to show or ask. You can always call someone up, walk over to their desk if you're in the office, and show them your work or ask what they think and get help and feedback. The idea that ShipShow Ask is the answer to all your problems is just not true. It definitely wasn't for us, and we definitely had a lot of learning to do aside from ShipShow Ask. But also, not opening a pull request and maybe committing to the main line is not a reason to avoid a conversation too. If you've got a cultural problem around talking about changes and talking about your standards, you can't automate that away. You can't rely on a process to solve that for you. You need to have the conversation, and you need to have an open enough culture to be able to do that. So there are some rules that enable ShipShow Ask. You can't rely on code review to merge PRs. Everyone needs to be able to play. You can't create a hierarchy of people who are allowed to kind of decide for themselves and people who aren't. You need to be able to trust everyone, otherwise it undermines the whole point. You need to have great CI and CD. You need to have a strong baseline belief that CD will keep you safe. And if you don't, that's where we spent our time first to get to a point where we could adopt this. And you need to subscribe to the idea that branches shouldn't live for a long time. No feature branches here. You need to be able to kind of be able to keep all of the changes in your head. If a change is so big that it needs a feature branch, you probably can't keep it in your head either. So this is ShipShow Ask. Well worth a read, in my opinion. We adopted it. It works really well. The one thing we haven't spoken about, though, is what if something goes wrong? What if someone could have spotted that problem? Well, to fix that, it depends. It depends a lot on the tech choices you've made, on kind of the culture of your company. Here are some things that we found useful. Phased rollouts. Not exposing the changes that you're making until you're totally sure that they work. Perhaps dog-fooding them with your internal staff. Perhaps doing an incremental 5% a day rollout and making sure that, customer support don't get inundated. Feature flags. By default, we don't release a change to anyone. Every change we make by default is hidden away until a quality engineer and a product manager are happy. That way we keep advice sacred, that we always reach the correct advice outcomes. And we have the same standards for feature flagged code as we do non-feature flagged code. QAs will not accept untested feature flag code. It's just as risky, and we need to have the same process. Loosely coupled architecture. If you have an architecture that embraces failure and allows you to fail, you're going to find it a lot easier to kind of recover when something goes wrong if you don't need a synchronous response for everything. And defensive alerting. So you could spend an afternoon coding for a scenario that you think might happen, but you're not sure. Or you could put an alert and chuck that event out into the dead letter queue. So these are some things that have worked for us, and they've worked to help ensure that even if something's wrong, most users don't see it. And someone using a feature flag, perhaps a product manager or a quality engineer, will spot it. And our feedback loop is short enough that we can then go and fix it before the code's ever reviewed. So what have we learned? We value shifting left, using RFCs and test kickoffs for behavior, linting, automation, and agreement for structure. We're not going to try and automate trust. It's a cultural problem that has a cultural solution as well. And we protect the users. This isn't like a Nigel Farage tribute band. I was supposed to change the slide. But we default to kind of showing users nothing and keeping our changes behind closed doors so that we can unblock engineers and make sure that they can test their assumptions in production and keep advice sacred. So, did it work for us? In short, yes. There's a kind of technical answer. So, these are two of our DORA metrics from the DevOps Research Assessment team at Google. Deployments per month has over doubled in the past 6 months. We've started doing ship show ask and adopting all these kind of failure resiliency principles. And change failure rate, this is the number of deployments that, or the proportion of deployments that someone's got paid, the proportion of deployments that cause an incident over time. And this has gone down to 0. So if this is interesting, we're hiring for a senior right now and more people next year. I think the band is 56 to 83 for senior. So come and chat to me after if it's interesting. I've popped some links on the side. Yeah, thank you very much for listening.
Two or three questions. Thank you very much, Luke. Got time for 2 or 3 questions. That was great. Thank you. The big ooh was not necessarily what I do now because I'm responsible for my own library. So I PR my own stuff and go, this looks good to me, and I merge my own stuff. Any questions? See a couple. Tell us getting close to Christmas and we're getting this kind of level of trolling. No, it's my job to come out to you.
Do I speak to the microphone or do I hold the microphone? Speak to the microphone, okay. No, my question, sorry. My question would be, how much effort did you need to put into like QA, setting up like good end-to-end tests or whatever you need to do to actually make sure that, because how do you know you don't actually have bugs? Like, maybe you do, you just don't know about it. Yeah. Okay.
Speaking to the podium more.
I think it's turned off.
Please.
Hello.
There we go.
Yeah, we definitely have bugs. The idea that we can kind of have 0 production defects is, we see as a myth. The thing that we like to talk about is 0 meaningful production defects, that stuff that's classed as financial advice, we have so much automation around, and we've invested an awful lot of time in relying on continuous integration and continuous delivery. You know, if a user clicks a button and kind of a modal goes a bit janky, yeah, I'm sure that we have some of those bugs, and I'm sure that a more rigorous approval process might help us solve some of that. I'm not totally sold on that, but yeah, we've had to invest a lot in QA for the things that matter for us. We accept that production defects are going to happen, but what we're aiming for is 0 meaningful production defects. We don't want to kind of get told off by the FCA.
There was one over here somewhere.
Yeah, so you mentioned that it requires an atmosphere, a culture of trust. How did you address the cultural issues to get to a point where you could do this, where you could trust people to say, okay, this needs an approval or this doesn't need an approval, I'll just merge it straight in?
Yeah, I think the thing that worked for us is a fairly militant QA process. That, to start with, if you read Atlassian's kind of blog post, there's actually kind of 6 stages to this. It might actually be on their talk. There's a talk by the old head of QA at Atlassian called The Future of QA. And they have 6 stages, and it kind of deals with your maturity to get to a point where you can trust each other. And the first stages are really militant. You cannot merge your PR until a QA approves it. And it's counterintuitive, right? If we're talking about no approvals for merging, like, let developers do what they want, great. To say, no, QAs are the boss here. But it's a step of building trust. You need your QAs to trust you and for you to listen to them in test kickoffs. We do that test kickoff and test review stage all the way through.
One at the front. Do we also have anything from the chat room? Do we have any questions from the chat room? No. Last one from the front.
I might be being a bit thick. I don't understand the difference between we need QA approval to merge and we can merge when we like behind a feature flag, and we need QA approval to turn off the feature flag.
Yeah, no, that's, in a way there's not a difference. But if you're working, the thing that we found is a lot of the technology we use is serverless. And a lot of the time you don't see what the impact of that is going to be until you actually deploy it. And we have lower environments, and we've invested in dev tooling that you can do that in your kind of in a loop in a way. But we have third parties as well, and we have other teams as well. And we want developers to be able to test those assumptions as early as possible. And if there's a 5-day gap between your inner and your outer loop, and then once you get to the outer loop, you find something's wrong, and then there's another 5-day gap. That's something that, yes, although technically we're not releasing to users without QA, it allows us to test our assumptions and move much quicker.
Cool. In that case, everyone give a big round of applause to Luke Brown. Right, I should just do my singing whilst our next speaker comes up. Yeah. Julia's looking at me like, is it me? So we've decided to sort of switch things up a bit. I don't know, but because we have normally sort of 25-minute sessions and 4 talks or whatever. So now we're going for now we just decided to throw some lightning talks into the mix. Do you want to come and plug in? Cool. So yeah, we're gonna have 3 lightning talks now. Starting with Julia Byro, who is Head of Developer Relations at Infobip. And I can't introduce the talk because it was still TBD. Is this going to behave? That's the extended one, so if you move it to it's normally the right with a Mac. If you move the window to the right. Did you want lapel mic as well? Lapel mic, lapel mic.
Of course. I'm sorry.
Do you want a lapel mic?
I'll manage with whatever.
Okay, cool. We've had all sorts of joys of technology. So it turns out that Linux laptops really, really don't like this. Make it okay. USB-C. That should work. Well, yeah. Cool. You ready to go? Do you want the handheld?
That one, this one.
Either. What's your
This
preference?
works, I think.
Can we turn the podium on? Thanks, Mike. Yep.
All right. Hi, everyone. Thank you so much for having me. This is going to be a very short one, so I'll keep it quick. I am Julia. I run developer relations over at Infobip, which is a cloud communications platform. We do communications of all sorts. Me being head of developer relations also means I do not write much code anymore, which is why this talk is code only. Recently, I actually looked into multi-factor authentication, different solutions, when pick what. Short takeaway is usually one OTP or 2FA via communication channel seems to be easy to implement, developer friendly, and globally available or most available to a lot of people. And quite often I get a question, okay, but when you say easy, what do you mean by easy? Well, I built it in 20 minutes. Gonna try to run it in 5. And as I work for Infobip, I'm going to use our own APIs for that, which I realize the screen is very small, so getting closer. There are other alternatives out there, but this is what we're running with tonight. So as for how to build an OTP solution, you can use a simple channel, send SMS, get the code, do your own logic. We actually have an API for it, and it's going to go in 4 stages. One, you create an application where you define sort of, oops, that's way too zoomed in. You know what, let's leave the docs code. To make things simpler, I'm going to be using our Node SDK, because way back when I was writing code, that is the one I was half competent at. And you can also use it if you so decide. And I did a little bit of preparation because I'm rusty and not in the new hip way. So, what do we have here? All I did to prepare this is I installed our Infobip Node SDK and .env so that we keep things clear. And to get started, you need an Infobip account, which lets you in our portal, where if you're a developer, you're going to have an API key and an API-based URL. Plug them in the .env file, and we are good to go. So first, instantiate Infobip with those creds, and then we give our application a name. Fair enough. Let's see how that goes. Okay, and then we have our response object. And for that, we have an application ID, which I'm going to carry over, because the next step is to set up a template. So when you get a one-time password or 2FA PIN, usually there's some text and the PIN slotted in. So we need to set up that template the first time around. These first 2 steps you only do once. And the next one is the create template, which is same set of credentials, and then a couple of things that we can play with. I'm just going to paste in the application ID, which I just created. And then a couple of things we can do. PIN type, this time simple, numeric. I'm going to go with your PIN is insert PIN, 4 digits English, and then sender ID, what shows up on the phone. You can do a couple of fun things more in the docs, but running with this. So, did I save it? I did, and okay. So now we have a template successfully created, and moving on to actually sending out the PIN. Probably this is the part where you're on the receiving end quite often. And for that, I'm going to need the application ID so that I know what application I'm using, and the template that we'll be using for it. So, credentials, and then slotting in application ID, grabbing it from the response. And message ID. And yes, streaming out my phone number again. We'll change that. Okay, so that has successfully been sent, although my phone is on silent. And for the verification part, ooh, that was sudden, we will need to take the PIN from my phone and the PIN ID from the response and make sure they match. So for that, pasting in the PIN ID. And the one I got was 1226. All right. Oh, thank you. Appreciate it. Ah. Copy pasting isn't one of my best skills either. There we go. Nice catch, thank you. Okay, and that's a successful verification. I'm not sure how I'm doing with time, but hopefully that was quick enough. And to pull it all together, just a little bit of code so that I don't manually copy and paste things as they come back from responses. But just to answer the question I usually get, how quick is it? Someone who doesn't write code that often can make it work in 5 minutes. So I do thank you.
Cool. Big round of applause for you, Neil Byron. Thank you very much. I think we're probably not going to take Q&A for the lightning talk sessions, but if anyone, are you going to be in the pub afterwards?
Oh, I'm definitely around. Happy to talk about this.
Cool.
Communication.
So if anyone's going to the pub afterwards, if you want to find out more about how InfoBip's 2FA works and the stuff that Julia sent, then go and chat to her. Cool. So another round of applause, and I'll get our next speaker on. This is a MacBook, so it should work nice and cleanly in theory. Our next speaker, for anyone that comes to, has been a regular attendee of, I was going to say Brum.js, but to be honest, like any kind of tech meetup in the past 5 years, 6 years, 7 years.
Long enough that I've lost count.
Lost count. Might be familiar with Ben Paddock. If you don't know, Ben's a senior developer or tech lead. I can't remember. Flirt between the two.
Just a ranty, opinionated person that's been in this game far too long. Senior engineer.
A senior engineer, and you can tell because of the amount of the miserable cynicism in his voice. So, here to impart some knowledge that comes from that kind of misery, I feel. We have a people-focused talk from Ben, so round of applause for Ben, and we're on rewriting our quotes, rewriting software.
Thank you very much. So my name is Ben Paddock. I'm a senior engineer at The Economist. I think you all know who The Economist is. We're over the road in Church Street, got a lovely office. We're also hiring, who wasn't these days. But we're not going to be talking about that. We're going to be talking about rewriting our approach to software development. So this has mainly been a cathartic thing for me, where I've come up with hopefully appropriate memes to describe the situation, but I'm sure many of you have been thinking, yes, I'm dealing with this pile of every day and I wish I could rewrite it. So imagine a situation where you've been given permission to rewrite it and you're going to kick it off. Well, unfortunately, it doesn't always work out that way. And before, during, after, I've felt like this many a time. It's a pain, isn't it? And unfortunately, as you'll know, humans are great at repeating history. I'm glad someone got the reference there. It's a great film. So I really want to kind of try and say that let's avoid repeating ourselves. The TLDR is that we should just avoid rewrites at all possible. Why is that? Well, if you're going to be rewriting a system, you're going to be juggling two systems at once. You need to know how the current one works, how the new one works, and you're going to have to migrate. And it is a headache because you've got to migrate your data or users, and it's a bit like flying an airplane and changing the engines whilst it's still in flight. Don't try that at home. So dual running, you will be spending a lot of energy doing this, and we're not all Forrest Gumps. And then, this classic one is product don't care, your users don't care, they still want working software and they want new features. So guess what? You're going to have to put it in one system or the other. Sometimes it makes sense because you haven't got time and it needs to go out the door. It goes in the current one, and then you've got to migrate that as well. We need to break the cycle. We can rewrite the rules. So here's some pointers about doing it. Firstly, it's really good to be in an environment where you are given the space to evaluate your technology choices, experiment, figure out the expensive stuff, the complicated stuff up front, make your mistakes. Make mistakes in production too, as Luke said, but you should always have the freedom to do this. Similarly, once you've made some choices, you're probably going to have to change your mind. So, you know, all the good stuff, the solid principles, all stuff you all know as engineers, protect yourself from the changes, factor it in the work that you're going to do. Software development is a crystal ball. You just don't know what's going to happen sometimes. This one, we all know this, but getting into a culture of refactoring little and often. So don't put it in big tickets. The Scout refactoring, as Luke mentioned earlier, is a great example. Get into the habit of putting it into the work that you do. Buffer your estimates based on it. Keep chipping away. And if you're struggling where to go, focus on code churn. If your system's becoming a problem, there's usually lots of code churn and things are becoming complicated. Focus on that. There's stuff that you'll want to rewrite that just works and doesn't change much. You can leave that alone. Focus on the code churn. Upgrade all the time. Especially in JavaScript, there's a new framework coming out every day and new versions, and it's a pain. But one day, you'll have a feature that isn't supported, and you're 5 versions behind, and then you have an entire roadmap plan to getting on an upgrade. You can even work with third parties where you're contractually obliged to be within certain versions. So upgrade all the things. Strive to reduce accidental complexity. By this, we've got incidental complexity, which is the domain of the problem you're trying to solve. But basically, don't be too clever. Just do the simplest thing possible that works, and you'll be well on your way. And tidy up after yourself. All the feature flags that you've put in, all the experiments, whatever's worked and what hasn't, make sure that if there's not any value, get rid of it afterwards, because you will end up like this guy. This is why I'm jaded, because I've been that guy. Like, how does this stuff work? Did we even need it anymore? Don't get into that situation in the first place. Which kind of leads on to this. Please, please, please do not put prototypes in production. If you need to test something, do it cheaply, validate it, even do it by pen and paper if you have to. Figure out what works, throw it away, and when you know what works, do it properly. And we've got to be honest here. We're doing software for users and for product. We've got to keep product honest, so they can't keep pivoting every 5 seconds. You need to help them on their journey. But also you have to be honest with them, and all the points that I've gone through. When you want to deliver something, don't be a feature factory. Consider all these points and tell them why. I think it's been 5 minutes, but as Chat AI, this thing is like big and trendy, I thought I'd ask for the AI's opinion. And it's given an answer which is great, because as a senior developer, I always say it depends, which is pretty much what's happening here. Thank you very much.
Came in under time.
Sorry?
It came in under time.
Oh.
Thanks. There's a lot of parallels to Luke's talk in that one, I think, and then a lot of things where I'm just slowly kind of nodding along to that. Not that I worked at a startup where every single feature was basically not ready for production, and they're like, yeah, but we need to make money, get it in. So yeah. Cool. So everybody give a round of applause to Ben Paddock. Thanks very much, Ben. Got our final likely talk. Justin's looking like, is it me? And this is going to be really interesting. So as a PHP developer, I have this, our package manager is called Composer. And whenever I do Docker Composer up every time, and it fails. Every time. Well, I say it fails. It mostly fails because Docker Compose, I don't know how to Docker. But the good news is that Justin works at Docker, so hopefully he knows what he's doing. But you don't have to worry about the AV, because that's not worked for pretty much anyone.
Is this the USB-C one?
Yeah. If you go in for that and then put that into the...
Huh?
Then put the HDMI into the USB-C and see what happens. I thought these things were designed for Macs, but I'm not convinced. Oh. Drum roll.
Aha!
Well, that looks like a desktop.
It works.
It works. It just works. Just like a Mac.
No. There we go.
Yeah, okay. Right, round of applause for Justin Chadwell.
So, so I've got a quick idea. Who here has had the misfortune of ever having to work with Auto Tools? Awesome. The rest of you don't know what you're missing. It's really kind of an interesting thing. Most of it is wrong. There's one feature it does right that I'd love to talk about. So a quick bit about me. I mostly work on system-level programming, hence the familiarity with low-level system build tools and things like that. I like providing good developer experiences, which is quite difficult to do with the above, as I'll explain. And I'm currently working on at Docker on all things Docker build related, and I like talking about that. So, let's walk through like a kind of reasonably common like scenario as you might build a product, you might scale out, scale up. So you have a front end that you want to deploy to a user server web page. So you end up writing HTML, you write some CSS, and you write some JavaScript. All is good, all is fine with the world. Internet Explorer exists. You have a problem now. If you want compatibility with this, or other browsers, you need to have some sort of way. You don't want to have to write all the stuff that does that. So what you do is you separate it out. What you want to do is you want to write nice HTML and nice CSS and nice JavaScript and turn that into compiled HTML, compiled CSS, compiled JavaScript. And at this step, what we've done is we've now split it out. We now have a build step. We are transforming code into more code. And this is kind of the start of any build system. Everything gets more complicated from here. Because now what happens if we want to save things? Maybe we want a server somewhere. So now we have two things. We're now building a front end and a back end. Keep in mind all of the complexity that was in the front end, we're probably doing equal complexity in a back end. And so, maybe everything is fine until we have different architectures. ARM, Intel, PowerPC, RISC-V, many exotic variants exist and are the bane of my existence. So, now you have all this complexity. Okay, so we solve this. We build for different platforms, one on every single one of them. And now everyone's happy, right? Except no, what happens if we have a bug? We can't debug it because now the front-end code is all compiled and it's a mess. And how do we work that out? Well, we can build source maps and we have solutions for dealing with these. But eventually you can kind of see probably where this is going. I can just keep adding to this diagram forever and ever and ever. It really goes on. We want things like debug symbols in our server. We want hot reloading because we want nice development experiences. We want to optimize differently for production and debug environments. And above all, this needs to be really quick so that users don't notice it, because they do notice it and they get upset. So, some tools try and handle all of this complexity by just getting rid of it. Lots of build tools out there, build systems will go, okay, well, we don't need any of these fancy things. We're just going to keep it really simple. All you want to do is compile thing to other thing. That first example, that's all you want. We can get rid of everything else. The problem is, those extra features are really useful. We want fast optimization level. We want hot reloading. Users want all of these things. And just getting rid of 90% of the problems doesn't mean that users are happy. It just means they don't get these features. This is a complex problem, and we need a way to deliver this. If we don't solve these complex problems, users will go to a tool that does solve those. So how do we actually build tools that solve this complexity, but are actually nice to use? So this is kind of where Auto Tools is right. Auto Tools, even if you don't recognize it, you might recognize these three simple commands. You clone a project, you run the configure script, make build, make install, and that's your software built. That's all of it. There's no extra fancy stuff. If you don't have a dependency that's not there, it will either go and fetch it or tell you to go and install it. Everything else about Auto Tools is complicated, but this bit, the bit that you see as the end user as you're building it, is wonderfully simple. It doesn't matter what compiler you're using, what platform you're on, what operating system, none of that. Doesn't matter. It's these commands for everything, and that's where it's correct. So I kind of want to introduce like the car model for dev tools, which is something I've come up with. It's terrible. But there's 3 levels for building a developer tool. At the very bottom, you have an engine. Your engine is all of your complexity. It's how you do all of these builds. That's how you do hot reloading, debug symbols, optimizations. And if, you're a tool like GCC or a compiler, that's where you stop. There's nothing else. That's the user's problem now. But if you're a bit better, what you do is you build kind of hood over it. You build something that's a bit easier. The main engine is still kind of roughly hidden from sight, but all the main interesting components you can just kind of pick and prod at. This is where your advanced users are going to sit. They're going to maybe play with advanced settings, But at the end of the day, this is still complicated. Not everyone who drives a car needs to do this. And so what you do is you finally build your driver's seat. This is where most of your users sit. They have nice, easy-to-use defaults. They have the configure, build, install step. Anyone else, they can dive deeper and deeper into the model, but you can put all of your simple parts at the top. So if there's any takeaway, build your developer tools like this. Don't build tools that are really complicated or can't do anything by removing all the complexity. Hide your complexity down, but always let users get down to it if they really want to. And that's kind of, yeah, that's a lot of the tooling that I helped to build. And so, yeah, thank you very much.
Cool, thank you very much. God, that really was a lightning talk, wasn't it? It was like bang, bang, bang. Right, so, Eli, please step up to the stage. Thank you very much to all of our lightning talks. It's nice to sort of mix it up a little bit. And now we have our last talk of the evening, and I'll get your... we start praying to the AV gods. How? I don't understand why that didn't work. Is it because it was USB-C?
I put it in the USB-C connector, yeah. Screen display.
Right.
Mirror. Apply. It's doing it. It's doing it. Woohoo!
And boom goes the dynamite. Right. So now officially fun employed, which I know is actually a which I know is a terrible term for people that are not employed at the moment, considering that tech is not exactly the most fun.
No, I've got something lined up. I'm good.
There you go. Okay, so that's the reason why I can say it. It's like fun employed for now.
Actually fun employed, not stressful searching for a job. But
That's two very, very different situations. Here to speak on You Shall Not Password, we're going to have a bit of a security talk. So a big hand of applause. A big round of applause for Eli Holderness.
Right, this is technically not a lightning talk, but the full version is 45 minutes, so I've had to cut some. Let's hope we get through it all. I am here today to talk to you about authenticating your users over the web. Thank you to Julia for the talk earlier on 2FA. We're going to be talking about some of that at a slightly higher level, less actually in the code. So today I'm going to talk to you about what authentication actually is and why you need it, common ways that we do it, and how to do it well. So, what actually is authentication? Let's say that I've built something. I've built a web app. And ideally, I have at least one user. And this user has stuff. They've got things like maybe some payment information. Maybe they've got a handle that they want to be able to post under. And as the owner and maintainer of this web app, I want to be able to administrate that. I want to be able to store that data about them, control whether or not they're allowed to post under that username. This is all well and good, but ideally, I don't just have one user, I've got lots of users. And I need to be able to make sure that only this one has access to their stuff. In other words, user stories that we all know and love. As a web service provider, I want to verify that a given user of my service corresponds to a given identity that I understand, so that I can appropriately control whether or not they have access to data and actions, right? So, how can we solve this problem? It turns out identity is really hard to define. Like, philosophically, what makes one person different than another is something you can spend the rest of your life talking about. But we're developers, so we use abstractions instead. Unfortunately, abstractions leak. They are only ever approximate, and they can fail. So, here are some abstractions you may be familiar with. Username and password for authentication. You've got biometrics, you've got SSO, you've got authenticator apps, and you have SMS-based 2FA. It can all get a little bit overwhelming. So, let's look at one an example that we're probably all familiar with, usernames and passwords. The flow for authenticating this way is pretty simple. You've got your user, you've got the web client that they're using to access the web service, and you've got a server that serves up that web client. So the user goes to log in, they put in their username and password, the client sends those on to the server goes, yep, that's correct, well done, and goes back to the client, it says, yes, this is correct, you can let this person into their web app. So far, so good. Under this model, we're using knowledge of this password as a proxy for identity. We use it assuming that if you know this password, you are this person. So in this model, it's really important to make sure that we know who knows that password. The user has to, of course, that's the whole point. The client doesn't have to, it can just pass through that information to the server, encrypted, TLS, all that good stuff. The server is a little bit more interesting in this model, however. The server has the following responsibilities. It needs to be able to verify that the password the user has supplied is correct, and it also needs to protect that password from being leaked to the outside world. Again, this password is equivalent to identity. If anybody gets hold of it, they can pretend to be that person. This is bad. One way we could potentially solve this problem is simply by storing records that look like this. Here's my username, and here's my password. If the server is compromised, this is super bad because all of those passwords are now out there in the wild. One way we get around this is by using hash functions. These are one-way functions, irreversible, and we take our password, we put some random data on the end that's generated on a per-user basis, and then we shove that into the hash function, and we get out this big, long, incomprehensible string. And we store that instead along with the little bit of random data. And this is called a salted hash. So when the password comes in from the client, we can append that salt, shove it into our hash function, and if the outputs match what's the second half there of that record, then we know that we're good and the password was correct. This means the server doesn't have to store the password directly. It also means that two people with the same password don't have the same salted hash. However, if somebody does get hold of your salted hash, really, really wants to crack your password, and your password is made up of like common English words like Eli's password, it can still be compromised, right? What you end up with is, for this system to be secure, users needing to remember passwords that look like this in the first place. While we're talking about the user, let's consider the user can forget their password. The user could be tricked into giving away their password. This is what phishing attacks are. And if the user has remembered a really good, strong password, they might be tempted to reuse it in more than one place. And therefore, if it's compromised in one place, an attacker can go, oh, I'm going to take that password and put it in all the other places. That person might have an account. And then those accounts are compromised too. So, how can we do better? This is where the idea of multi-factor authentication comes in. Little stop to the name of the talk. We have had one factor authentication. What about second factor? This is the idea that we've got these abstractions and they can fail, but to protect against one failure, we can require multiple successes. You most commonly see this as two-factor authentication, hence 2FA. So, these abstractions are also called factors, proxies for identity. They commonly fall into things you know, without loss of generality, these are passwords, essentially. Things you have, like a phone or a hardware token, and things you are, like biometrics, which are usually used to unlock things you have. So, what are some options for multi-factor authentication? I'm going to start with my personal favorite, which is hardware authentication tokens. These are things like a YubiKey. You can also get them built into larger devices like a phone or a laptop. A lot of newer laptops have these built in, as how the face scanning thing that Windows does now, that's using a hardware token. And the way that you use them to authenticate is you need to understand a little bit of public key cryptography in order to know how they work. This is a system where you have a private key and a public key. The private key, clue is in the name, keep that secret. The public key you share to anybody that you want to be able to know who you are. Whenever you sign something with your private key and with a hardware token that is baked in at the hardware level, it's physically represented by that object, you can sign any message that you send with that private key, and then whoever's receiving it can use their knowledge of your public key to verify that you sent it. This is really cool because it allows you to prove ownership of a secret, big prime number, but with hardware tokens, prove ownership of a physical object without having to give away the secret that is baked in within it. So, if I have a hardware token and I want to log into a web service, how does it work? Well, you've got your user, the web client, and the server again. And the client, and the client says, hey user, please present to me your hardware token. The user does that, and then that authentication challenge from the server gets passed directly onto that hardware token, The user does something like pressing a button or providing a fingerprint to make the hardware token do its thing. It signs that with the private key and then passes that back onto the client, passes it back onto the server, which uses its knowledge of the public key to verify that that actual hardware token was the correct one. And then it can go back to the web app and say, all is well, let them in. And this is really, really cool for 3 reasons that I'm going to call out. The first is that the device, your hardware token, actually knows about the web service that's making the authentication challenge. So if I go to goggle.com and put in my YubiKey, my YubiKey is not going to do anything because it knows that actually it should be Google. Well, it doesn't have to know it should be Google, but it knows it doesn't know who Goggle is, right? This gives you really strong protection against phishing attacks where a website is faking being some other website. It's a lot harder to fool hardware than people. Well, in certain cases. In this case, particularly. That authentication challenge goes directly to the device itself. The private key never actually leaves that device. The cryptography all happens within that piece of hardware. The challenge comes in, it's signed in situ, and the signed response is passed back out. This means that no matter what you do with a hardware token, you cannot actually, even if my laptop is full of malware, the hardware, the private key cannot be extracted from it. That secret is safe. The other thing is that it can require user presence. So I mentioned you might have to press a button on a roaming authenticator or do some kind of provide biometrics on a platform authenticator. This means that, let's say I leave my YubiKey plugged into my malware-ridden laptop and it's spamming the YubiKey with requests trying to reverse engineer the private key. I'd have to be there pressing the button every single time. So it provides a really strong defense against that too. So these are amazing. Everybody should have them. Everyone should love them. Why don't they? They are expensive. My YubiKey cost, I think, £60, which, you want a tax salary, it's fine. I like it, I use it, I love it. But not everybody can afford that. The other thing is, they're physical objects. You can lose them. I have ADHD. I lose things constantly. And you can get around this by having multiples and having backups. But then, again, they're expensive. So that's hardware tokens. Another option is one-time passwords, wonderfully demonstrated for us earlier today. The way that these work is you get a code to your phone. This could be through an authenticator app as well, but for this purpose of this example, I'm going to talk about text. And the flow will be familiar to many people. You go to your web app and you say, I'd like to log in, and the web app goes to the server and says, please generate a one-time password, send it to that person's phone. That happens, the user looks at the code, types it in, and the web app is able to verify that this code is correct, either on its own or by making a separate call to the server, and lets you log in. This is great. People have phones. People are more likely to have a phone that can receive texts than they are a hardware token. Lots of people, for example, in vast space, sort of rural areas, particularly in Africa, there's a lot of places where people are using text and data to do all kinds of incredible things like the M-Pesa system. I don't know if anyone's heard of that. You can far more easily rely on your users having access to text than you can to things like a hardware token. However, you can't necessarily always rely on people having signal. Signal in my house in Sheffield is absolutely garbage. So the other thing about these is that if you've got a SIM card, you can very easily go into, let's say I'm on EE and somebody else takes a SIM card and goes to Vodafone and says, hey, I lost my phone, can I have my old number back? And they give my number. There is not enough federation between phone networks to stop that happening, and now they're receiving texts that are meant to go to me. So I think in 2018, some of Reddit's core moderation team were using text-based MFA, and they got compromised for this reason, because of this social engineering attack. The other thing, of course, is that you can lose your phone. So if somebody loses their phone that we're using as a proxy for their identity, you need some way for them to be able to recover their account. Another option is Magic Link login. And this is quite similar to text-based login with a few little differences. If you use Slack, you might be familiar. Slack uses this, it's very, very cool. And how it works is the following. I'm a user, I go to my web service and I say, here's my email, send me a link so that I can log in. The client goes to the server, says, please generate a link to an authenticator session, a link that contains a token that I can use to verify this user, and send it to their email. The server does that, and the person goes to their email, clicks on a link, and it takes them into the web app where they're authenticated. One of the reasons I like this over SMS-based 2FA is that if somebody is accessing your web service, you can be pretty sure that they have an internet connection. They're going to be able to access their email. Another is that you can't typo the code as you're like looking at your phone and putting it into your laptop. It's just a link that you click. Another is that you don't have the compromisability of SMS-based text that we just talked about. You're relying on the security of your email provider, and if things are going wrong there, then you probably have bigger problems. Of course, you do still have the potential problem of people losing access to their emails. At my last job, we saw this not infrequently. People would sign up with a student account, and then they'd graduate, lose access, and suddenly the thing we were using as the identifier of who this person is was no longer reliable. So, we've seen some options for multi-factor authentication. Think about how many online accounts you have. Facebook, Twitter, Tumblr, Etsy, eBay, Reddit, whatever. And think about setting up two-factor authentication for all of them. Not all of them are going to have the same options. Maybe not everywhere lets you use your hardware token. Maybe some places require you to use text-based MFA. Or think about how many online accounts you have as an employee. Slack, Jira, Confluence, Bitbucket, whatever. And then imagine that you are the sysadmin for these systems. You have however many employees, all of their accounts, all of their second-factor authentication. This is a massive overhead, and it prevents people from using second factors of authentication, which is a shame because they really, really help keep your accounts secure. What we'd really like is we'd like to be able to centralize this somehow and have one place where we could just like concentrate all of that security and see that benefit reflected everywhere. This is the idea of single sign-on. In single sign-on world, you have a service provider. This is the web app that we've been using in examples so far. And then you have a new concept of the identity provider, this entity whose entire job is to manage authentication and verify people's identity. When you log into something with SSO, or when you log into your identity provider, this means that you have one place that you can add in all of your extra security, your hardware tokens, your many factors of authentication, and also one place to update information, like maybe I changed my name or moved house. And then you can see those changes reflected across everywhere that you use that identity with. If I want to log in using single sign-on, this is the sort of abstract version. I go to my service provider and I say I'd like to log in. My service provider then redirects me to the identity provider. And this is where I do all of my, complicated two-factor authentication, all of the overhead, all of that. And then I am authenticated there, and I am then redirected back to the service provider along with some kind of token of proof that the service provider trusts and can use to say, yes, I now know who this person is because the identity provider has told me. If you were already logged in your browser session to your identity provider, this is seamless, right? And then you're authenticated with your web app. It's basically the idea of delegating authentication. Division of labor. Have one place where this is its sole job is to do this and make it really good at that. Web services under this model don't need to store things like your password. They don't need to store necessarily even things like your payment information. There are models for requesting that from the identity server. It means that if my yarn shop gets hacked, they don't have access to anything that they could use to impersonate me. All they know is that I used Google to log in. It also means that users don't need to remember lots of passwords. They can have one strong password and one place that they use all of their security, extra security things like hardware tokens. There are drawbacks. If your identity provider is compromised, suddenly your identities with all of these other web apps are compromised. I used to kind of make light of this and say, well, your identity provider has a much bigger security budget than your small web apps do, right? Like, Google's security budget is huge, and they've got some of the best security teams in the world. Yes, you're putting all your eggs in one basket, but that basket is Fort Knox. However, it does happen that identity providers can be compromised. Okta had a security breach. Twitter got bought by Elon Musk. It does happen, and there are ways to, if you're using Twitter for OAuth and as your SSO provider, there are things you can do about that to decouple them. But it is a risk that you're taking when you put all of your eggs into one basket like this. There is a section that I've cut here about the ways to implement SSO. Please come and find me afterwards to talk about it, because there's some really weird and cool and cursed stuff that goes on to actually make this work. But I've had to cut it in the interest of not keeping you all here for the rest of the night. So, last section. What makes an authentication system good? Security, obviously. If you've built something and it's not secure, you might as well not have built it. You might as well keep my money in my mattress and not use an online bank. And to that end, I would like to revisit the example that we started off with, username and password-based authentication. If implemented properly, this is secure. You know, if everybody is remembering passwords that look like this, it's secure. I mean, they need to remember a lot of passwords that look like this. True, yeah. And password managers do go some way towards solving the usability problem of this system, but it still leads to insecure behaviors like people writing down passwords, people reusing passwords, people appending to, exclamation point, whatever, to their passwords. And if something is hard to use securely, that makes it insecure. It doesn't just have to be in theory secure, it has to be secure in practice too. And just because your users might be developers doesn't mean you can assume they're going to be good at this stuff. One of the cleverest engineers I ever knew pasted his master password into Slack. It happens. You cannot rely on perfect user behavior because it's just not a reliable assumption, and nor should it be. So I would say that security and ease of use are both things you need to consider. Sometimes you might think that these are in tension. To that end, I would refer to an example that would have been in the longer version of this talk, which is SAML, which is one of the ways of implementing SSO. The Spark Notes is, if implemented correctly, it's both incredibly usable and secure. But it's an absolute pain to implement securely because you've got to consider like loads of different libraries and you've got to understand how XML canonicalization works, and it's just come find me in the bar afterwards. It's a bad time. You need to have something that's able to be implemented securely. If it's hard to implement securely, it's basically the flip side of your usability problem, but for developers, right? So I would argue that there are 3 things you need to consider when you're deciding how to build an authentication system for your app. And it's worth mentioning, you don't have to reinvent the wheel with any of, like, you know, if you choose to do text-based MFA, you've got libraries that you can do that and APIs. But when you're choosing which ones you're going to use, you're going to need to think about the trade-offs involved in each of these areas. And they're going to be context-dependent. Your security posture is going to inform your stance on the first one. Ease of use will depend on who your users are. Do they have access to hardware tokens or not? Ease of implementation is going to depend on the dev team that you have available. You know, maybe you have a team of crack cryptographers who are going to, you know, write their own one-time password system or something. Or maybe you're going to rely on a third-party library, you know. But I would say that these are the things you need to consider when you want to decide how to authenticate your users. And it's worth understanding a little bit about how each of the options that you might consider actually work in order to better make this decision. Yeah, a little bit of a rambling wrap up there, but that is where I will leave it. We have learned what authentication is and why we need it. We've learned a common way to do it and why it's actually a lot harder than you might think. And we have talked about how to do it well, and that usability matters not just for your users, but for us as developers as well. Thank you very much.
Cool. Thank you very much.
How was that on time?
Oh, you're on time. Oh. There you go. Right. Any questions? There's a mountain of stuff to digest in there. So we've got time for maybe sort of like maybe 2-3 questions.
Hi, this isn't so much a question as it is just an interesting note. Cloudflare currently have a good of the internet, or a for the good of the internet offer on YubiKeys, where you can get them for $10 instead of like 50 quid or however much they're normally asking for. So if you want a YubiKey, it might be worth looking into.
Oh, very nice. Yes,
signing
cool.
up for Cloudflare and nicking their offer whilst it lasts.
Cool.
Going some way towards laundering their reputation after the Kiwi Farms thing, I see.
I didn't interrupt that because I thought you were going to say it's a question, not a statement, but I know Ryan, so he wouldn't say that. It's fine. You're not being shilled by Cloudflare, are you? There we go. Useful tip of the day. Hands up.
Hi. Quick kind of question, I guess, on the GDPR point. If you're using a third-party provider and that gets compromised, does that mean you're both in trouble?
Sorry, if
If you're using a third-party password or authentication provider, and and everything is compromised, does that mean that both of you are in trouble now?
I don't know. So it would depend what you you in this instance being the web app developer, it would depend what you stored on your servers. In terms of like, the data storage and be able to delete people's records and whatever. I think it would be specific to the implementation that you're using and like what you're actually storing.
So if say I used Google, it would be Google who would be at fault if the password was compromised.
Yeah, I think the short answer is I don't know.
Okay.
I think it would depend on what specific terms were breached and in what way, and I don't know. That is an interesting one.
I think we had this with the Okta breach because Okta are then liable for the majority of it because they're a single sign-on service. But then, for the local services, you then get all of your users to change their sign-on because that's data that's held within your servers. So your bit is technically easy. Cleaning up the mess that they've created, that's their problem. That's as far as from what I can remember from the Okta cleanup.
Yeah, I think you wouldn't be necessarily responsible for the breach happening because obviously that's out of your control, but I think you would then have some duty of care to your customers, to your users, to make sure that they were being protected and weren't continuing to use a single sign-on service that was broken.
Yeah, I've seen it at enterprise level when that happens. They basically just, one person in like sysadmin basically presses the nuclear button and says, okay, Monday morning you've all got new passwords, you've got to set them, and that's it. Mm-hmm. So that covers you. Anyone else and anyone from the chat rooms? There was one over there, okay.
Single sign-on services, they're not single because there's like 50 million of them and they all hate one another. And I'm never going to be able to sign into Amazon with my Google account, and they're all looking to IPO and take a load of money rather than care about my security.
Yeah,
How is this problem solved?
Yeah, the single there refers to the idea that you as a user have to sign on a single time, right? And if you're already authenticated and with your cookies, yes, turns out this is a useful thing that people want, and therefore we now have 1 million of them. How is this problem solved? Well, I guess it depends what you consider to be an ideal solution. I would quite like the idea that we all stand up our own identity servers and they're all somehow federated. I think that requires a slightly different world than the one we live in. Hey, maybe with the Fediverse, catch me on Mastodon, my handle's in there. Yeah, I don't know. I mean, it's part of the problem of you are putting all your eggs in one basket, and are you going to choose one that makes it super easy to get to your email like Google, or are you going to choose one that's dedicated for purpose like Auth0? I think I would prioritize. If the question is how to choose which one to go with, I would choose one that makes it as easy as possible to move away from it. So that if you do want to, for whatever reason, you don't have to, I don't know what the situation is if you want to go and unlink everything from your Twitter. I imagine it's probably quite painful. That would be a factor I'd consider strongly, is ability to shift around between different providers. I say with my entire life, depending on my Google account. So, do as I say, not as I do. But, yeah.
And any more? Cool. All right. Big round of applause for Eli Holness. Thank you very much. So I guess just before I round up, first of all, have we got any contenders that actually took photos and did? Oh my god! Right. Okay, I didn't actually expect that people would do it. Right. So come up to me once I've sort of signed off. I'll get my notes. Because, I'm really bad at anagrams. So it just remains for me to say, obviously, thank you very much for coming. Fusion depends on people actually, coming. So thank you, the audience. That's a prompt to clap. I mean, you don't have to. Thank you to my co-organisers, to Mike and Maria and James, and Andy's pointing at Maria for some reason. Sorry? Yeah, no, I've already said, were you not listening at the beginning? I said thanks to James for the website. Apparently I'm not doing my job properly. I said thanks to James for doing the website. And to Hannah, who is hiding somewhere. I can hear her laughing, because you always can. So thanks to my team. Thanks to our sponsors that make this happen, Goldman Sachs and Vonage. Obviously, thank you very, very much for Rudy's, as you can see, for stepping in pretty much at the last minute, and then an extra thanks for Hannah for going with Stuart through the German market with stacks of pizzas. So thanks to both of them for keeping you fed, and to Rudy's. We are going to Cozy Club afterwards. If you don't know where Cozy Club is, then come and speak to one of us, because we'll be going. If you've got any more questions for the speakers, I think they're all going to be there. So yes, just remains me to say thank you very much.